Hello, math humans. We're going to do 10.8 today. We're going to be talking about graphs of polar equations. So we're going to graph our polar equations using symmetry, our knowledge about the zeros, and then their max and min radii. And then we're going to explore kind of some cool polar graphs. So there's three types of symmetry that we like to talk about. Got a little Harry Potter playing in the background. But we want to consider symmetry about the polar axis, which is horizontal. And this might be an example of an equation. Notice that again it has cosine because cosine is our horizontal trig function. And then about pi over 2, which is our vertical axis, because sine is our vertical trig. And then about the polar, and I didn't give one of these because we'll talk about that later. So we're just going to do some examples. We're going to be graphing our polar equations by hand. So I want to graph r is equal to 4 sine theta, and we're going to do it by hand. And then I'll show you, we'll put it in our calculators because we can. All right, because this is sine, I know that it's going to be symmetric about pi over 2, okay? So then I'm going to make my table of values, okay? And I'm going to write r is equal to 4 sine theta, because remember our ordered pairs are going to be radius comma theta, okay? So we're going to find our thetas first. Since my graph is going to be symmetric about the vertical axis, I'm going to choose values in the first quadrant because then those will reflect symmetry across this vertical axis pi over 2. So I'm going to do the math first and then we'll plot points. So if I chose the angle pi over 6, remember, which is in your first quadrant, and I am going to draw, this is 30 degrees, so I'm going to draw this as pi over 6. And then if I put this into my function 4 sine theta, I'm going to get 4 times the sine of pi over 6, and so that's going to be 2, because you can't see the whole thing. Let's see if I can scoot it up a little bit. Okay, and then the next angle that I'm going to choose is pi over 3. Okay, pi over 3 is 60 degrees. Whoop. So it's going to be right there. Not a very straight line, but we get the general idea. So pi over 3 is 60, so I would get 4 sine pi over 3, and I'm going to get 2 radical 3. I don't know exactly what that value is, so I'm going to get the decimal equivalent because that's just going to help me put a point on my graph. And then I could do pi over 2, and I would have 4 sine pi over 2, and that's going to be 4. Pi over 2 is here, and then I had on my graph that I'm going to do pi, and I'll show you what happens when we choose that. So 4 sine pi is going to be 0. And if I really wanted a little bit more accuracy, I would have done, whoop, maybe pi over 4. So pi over 4 is 45 degrees. So I'm going to have 4 times the sine of pi over 4. So it's 4 times 1 over radical 2. And then if I get the decimal equivalent, because I didn't do that ahead of time, divided by second radical 2, I get 2.828. Alrighty, so now let's plot the points and we're going to talk about our symmetry. So I'm going to draw these guys over here. This would be 60, whoop, and then this is going to be my 45. So I will upload some graph paper for you, or you can do it like I am. On a test, I will give you the graph paper. So because we're in polar coordinates, we have circular graphs. So this is my handy dandy graph paper, okay? I think, did I get enough? 1, 2, 3, 4. Nothing's above a 4. So here's the way the symmetry works. So at pi over 6, and I'm going to put a little 2 right there, I'm going to have the 2. Well, symmetric across is going to go to the pi over 6 on this side, and so then I'm going to also have that value, okay? So notice that I took my pi over 6, the radius is 2, and then I reflected it across the vertical axis, and so then there's its counterpart over there. So pi over 3, 60 degrees, is going to be 1, 2, 3, almost at 3.5. reflect it across the axis, and it's going to be right there. Okay. At pi over 2, the radius is 4. It's sitting on the axis, so I don't need to reflect it because it just maps right back onto itself. And at pi, the radius is 0. So if you'll notice, when I connect my dots, oh, so pretty, I got a cute little circle. So that's supposed to be a circle. Alrighty, so now let's graph another one, just because we can. So this will be example number 2, and I'm going to graph r is equal to 3 plus 2 cosine theta, and again, we're going to do it by hand. Okay, so if you'll notice, I have a 3 plus 2. These two numbers are going to give me my maximum radius. So my maximum radius is going to be 5. If I subtract 3 minus 2, I get 1, and that's going to be my minimum radius. Okay? This is symmetric about the horizontal axis, so I'm going to choose values in the first quadrant and one in a couple in the second, and then I can reflect those. So let's do our table of values. So remember my points are theta, comma, bad math, r comma theta, okay? But we always graph theta first. So here's going to be my theta, and this is my r, which is 3 plus 2 cosine theta, okay? So I'm going to put my little coordinate system over here. I'm symmetric about the polar axis, the horizontal axis. So the first angle that I'm going to choose is 0. So when I substitute that in, I get r is 3 plus 2 times the cosine of 0, and that's going to give me a 5. So then I'm going to draw 1, 2, 3, 4, 5. That's kind of crappy circles, but we get the general idea. So my first radius, I'll do it in a different color, is going to be 1, 2, 3, 4, 5. Remember, we need at least one number on every axis. Since my graph is symmetric about the horizontal axis, that point doesn't go anywhere. So the next angle that I'm going to choose is pi over 3, and I'm going to get 3 plus 2 cosine pi over 3, and when I do that math, I get 4. Pi over 3 is a 60, so I'm going to draw that line right here. So this is going to be pi over 3, and at pi over 3, it is 4, so 1, 2, 3, this is 4, and then I need a pi over 3 down here. Oops, I missed. And then I'm going to go across the x-axis, 1, 2, 3, 4, and it's going to be about there. Okay. The next angle that I'm going to choose is pi over 2, and when I do that math, 3 plus 2 cosine pi over 2, I'm going to get 3. Okay. So at pi over 2, which is here, I'm going to have 1, 2, 3, and then when that reflects across this axis, 1, 2, 3, it's going to be here. Okay. And I'm going to put a 3 there because I don't have a number on the y-axis yet. My next angle that I'm going to choose is 2 pi over 3, okay? 2 pi over 3 technically is kind of up here. My graph is kind of crappy, but when I do that math, I get 3 plus 2 cosine 2 pi over 3, and I get 2. So this is a pi over 3, so this would be 2 pi over 3. Again, crappy graph. We'll just apologize now. 2. When I reflect it across, it's going to go right there, 2, okay? Notice that these points look a little bit different than the last one. They're changing shape a little bit. And then the next angle that I'm going to choose is pi, so I get 3 plus 2 cosine pi equals 1. So at pi, it's 1. It's sitting on the axis of reflection, therefore that one doesn't go anywhere. So let's talk about expectations while you're graphing. So on a test, you will have to fill in the table, okay, and you'll have to show your math on how you developed it. I will give you a coordinate system so that your graphs will turn out prettier. You're going to plot the points that you determined, and then you're going to connect the dots. So this is actually a really cool shape, and it's called a cardioid, because it looks kind of like a heart, okay? And so it's a really cool graph. So now what I'm going to do is I'm going to go and put my calculator in polar mode, okay? So you can see that I'm putting it in polar mode. I'm going to go to my y equals and clear what's there, and I'm going to do 3 plus 2 cosine theta. I'm going to check real quick that my calculator's in radians. I'm going to go back to my y equals, and I'm going to hit zoom 7, which is zoom trig. Okay, and it's kind of cool. It's not as pretty. Maybe if I do a zoom square, zoom 5, it will change the shape. Oh, there we go. Now it looks a little bit better. So that's kind of cool. There's my cardioid. So depending on the difference between your minimum radii, it can change the shape of your cardioid. So that's actually pretty cool. Alrighty. So we've talked about this already, but I'm going to go ahead and mention it again. So for my maximum R value, so for my maximum radius, I want you to remember first that sine and cosine oscillate between a plus or minus 1. So if you'll remember the graphs of the sine and cosine function, they oscillate between a plus or minus 1. So for the sine functions, the maximum radius is going to happen at the peak of the sine graphs, which is going to happen at pi over 2 and 3 pi over 2. So that's some information knowledge to help you get your function. Cosine of x, the maximum is going to happen when the radius is going to be at 0 and pi. And so we had a cosine function, so notice that my maximum radius phi happened at 0. Okay, so that's actually kind of cool. Okay, so then our generic formulas that we're working with in this particular section are going to be r is equal to a plus or minus b sine theta, and r is equal to a plus or minus b cosine theta. Your maximum radius is going to be the absolute value of a plus the absolute value of b. Remember, sines are just a direction. And then my minimum radius is going to be the absolute value of a minus the absolute value of b. All right. So now what I want to do is introduce you to some of the special curves. And it's really fun to draw these. Right when we started this chapter, I drew a rose curve for you. So we drew flowers. So that's actually the first shape that we're going to talk about. They are going to be rose curves. So the generic formula for those is r is equal to a cosine n theta, or r is equal to a sine n theta. A is going to determine the length of the petal, okay, because again, that's going to be either your max or your min radius. N is going to determine how many petals. So it's fun to play with that particular thing when you're graphing. An additional caveat, if n is odd, then it's going to be n petals. If n is even, then it's going to be 2n petals. Okay? So we're going to graph this particular formula just because we can. So r is equal to 4 cosine 6 theta. So again, your calculator has to be in radians. So I'm going to go into my window first, and I'm going to change my theta step to be 0.01. And what that's going to do is it's going to make my petals be much nice and smooth. Sorry, that was really bad grammar. Cosine 6 theta close. Okay, I'm going to delete that extra parentheses. And I'm going to do a zoom 7. All right, and here we're getting a flower. Isn't that so cool? 6 is even. Therefore, I'm going to have 12 petals as my calculator keeps doing its thing. I think that's about the coolest thing ever. And so I've just given you flowers for the day. So fun. So the next shape that I want to talk about is called a limacon. And it makes me think of leprechauns. So the equation is r is equal to a plus or minus b cosine theta, or r is equal to a plus or minus b sine theta. Remembering that the cosine and the sine determine the types of symmetry. This one would be about your horizontal axis, which is technically called the polar axis. And this one was going to be, ooh, today we have some frozen going on in the background. This one is going to be symmetric about your vertical axis, which is going to be your pi over 2 axis. So in this one, if A divided by B is less than 1, then it's going to be a limacon with an inner loop, which is really cool. Okay, and so before we move on, I'm going to show you this. I'm going to go back to my handy dandy grapher, and I write down the equation. So I'm going to have 2 plus 4 cosine theta. So if I do A divided by B, A divided by B is going to be 1, oops, that's a 4, 1/2, which is less than 1, so I should have an inner loop. So I'm going to go back to my y equals, and I'm going to enter 2 plus 4 cosine theta, close, and then I'm going to do my zoom 7. So here goes my handy dandy calculator. Oh, here comes the inner loop. Oh, it's going so slow. Really kind of cool. There it goes. So it's similar to a cardioid because notice it looks kind of like a heart on the outside shape, except now I have that inner loop. So just because we can, if I wanted to graph change my equation to be 2 sine theta and graph it. Okay, so again, I entered an equation that should be symmetric about the polar axis, or sorry, the vertical axis. Okay, so here's my limacon. Oh, all right. So it's kind of a cool looking limacon, but notice there's no inner loop on this one. So I entered the equation r is equal to 2 plus 2 sine theta. Well, a divided by b was 2 divided by 2, which is 1, which is not going to be less than 1. That's why we didn't get the inner loop on that one. Okay? All right. 2 more curves, and then we are done. The next special curve is a circle, and it's really nice to graph it in your calculator with polar coordinates. The equation is going to be r is equal to a cosine theta, or r is equal to a sine theta. So let's say I'm going to enter r is equal to 4 cosine theta. Again, our symmetry is going to happen about the polar axis. So I'm going to enter 4 cosine theta, close, and then I'm going to do my zoom 7. Alrighty, here comes my circle. Notice that it still looks like an ellipse. So if I did a zoom 5, which is a zoom square, zoom, oh, it's not done. It's taking some more laps. Now I can do a zoom 5. If I do a square axis, it's actually going to look more like a circle than it is an ellipse. So see, there's my nice, cute little ellipse. Notice the way it shows up. Notice your axis of symmetry. Okay, so that's kind of cool. So unlike when we graphed y is equal to plus or minus the square root of like 1 minus x squared, remember that when we would graph, we would get these gaps at the horizontal axis. Well, now if you do them in your calculator with polar coordinates, you get a nice, pretty circle. The next shape that I want to talk about, our last shape, is called a lemniscate. And I don't know where they come up with these names. But the equation is r squared is equal to a squared sine 2 theta, or r squared is equal to a squared cosine 2 theta. Okay? So we're going to enter, if I put this in my calculator, I still have to enter a plus or a minus. So I'm going to get r is equal to the positive square root of a squared sine 2 theta, and r is equal to the negative, and then a squared sine 2 theta. So let's enter the equation just to see what happens. So I'm going to do the square root of, as I try to get my computer to come back. Okay, I'm going to enter 9. Actually, that's probably going to be too big. So let's do 4, because 2 squared is 4, sine of 2 theta, and then we're going to enter a negative 4 sine 2 theta. Okay, so if we go to our y equals, I'm going to enter the second square root of 4 sine 2 theta, and then I'm going to enter the negative square root of 4 sine 2 theta, close, and then I'm going to hit graph. And actually, I'm going to stop. I'm going to go back and do my Zoom 7. All right, so let's see what happens. Okay, there's the first half. Here comes the second half. Notice it is the infinity symbol. So we have graphed to infinity and beyond. So here is my circle. My calculator's still doing his thing. He's still quite happy because it's going around multiple times. That's why the color has changed. But here is your axis of symmetry, and it graphed the infinity symbol. So that's what a lemniscate is. That's really pretty cool. Alrighty, that's it for today. I will see you soon.